Okay, let's continue. So, are there any questions? 27, good. I'll answer them all at the same time.
Yeah.
Any questions? Wait, so what did this method, this procedure right here tell us? If I have a regex, what can I produce for you? An NFA. Okay, well, does that prove that regexes have the same, recognize the regular languages? Could it be possible that an NFA has a language that a regular expression can't recognize? It's possible, because we only showed one direction of proof. We only showed you can go from a regex to an NFA. We never showed how to go from an NFA directly to a regex. But here's a method of proof that is actually not a good idea. Suppose your friend just says, oh, that's easy. Just take an NFA and then look at it like this and decompose it into each of the pieces and then construct the regex that way. Because all NFAs look like this, obviously. Is that a good method of proof? Here's a tip you should internalize. If someone tells you something is obvious or something is clear or it's just definitely true, what should you immediately think? It's not true. I've seen published papers in my own area that have obviously written in it, and right in that sentence, the proof is wrong. Okay? So whenever you see obviously, immediately put on your skeptical hat. Okay, well, so let's think about the question, what about going from an arbitrary NFA, not necessarily in this form, but just an arbitrary NFA, and I want to produce a regex for you. So this is a harder question because a regex is built up from simpler pieces. An NFA has transitions that can go from anywhere to anywhere. And states are final and non-final, whereas regexes don't even have the notion of what's final and not. So how would you even do that? Well, what we're going to do right now is we're going to build up the intuition from simple examples. And then from the simple examples, we can talk about how to do this in general. So let's think about the simplest possible NFA at all. Let's see. So let's suppose that we have an NFA that is exactly this. Just a single character, single transition, no other transitions, two states. What is a regex for this NFA? Yeah, so it's the example we had earlier. So the regex here is clearly A. So no issue here at all. Okay? Let's actually make it a little bit more complicated. So let's just have a state in the middle, and let's put A and B on it. So what is any regex at all that recognizes this, that has this language? AB. Is that the only regex that's possible? What's that?
Could it just be B?
Well, it has to go from the start state to the final state. Could I have A epsilon B? Yeah, that's possible. Could I have A epsilon B union empty set? Because remember, anything union empty set is whatever the thing was. It doesn't do anything. What if I said union epsilon? Is that different? Yeah. So this is actually a mistake students make all the time. Hint, hint. What we're saying here is we're unioning with a string itself. So we're adding a string in that wasn't there before. Whereas before with the empty set, we were unioning something that didn't have anything at all in it, so it didn't add anything extra. So be careful by saying union epsilon, oh, that's the same thing. It's not actually the same thing most of the time. But I'm going to do the simple example by saying A with B, and I'm going to put a little space in between for a reason I'll get to shortly. But any questions on that? Because, again, we're going to make it more complicated. It should be the motto of this class. We're going to make it more complicated. All right. So what about if in the center state, I'm going to put a self loop on C. What is a regex for this? AC star B. Okay. So that wasn't too hard. Let's say I don't like having to take 2 hops. I want a shortcut. I'm going to shortcut my way over to here. And I'm going to have this really fast path D that skips over this other path. What is a regex for this? Union D. Because I can either take the AC star B path, or I can take the D path down. Okay? Any questions on that? Yeah.
Would you have to put the ACB in parentheses?
I could. So in some cases, whenever we're dealing with concatenation and there's unions on the inside, it'd be wise to put parentheses around. Just like when you're doing multiplication and you have plus in the middle, addition, you better put parentheses around it. So here, there's nothing like that, so I don't have to worry, but you're right. I should put parentheses around these. It actually won't make a difference, but purely for readability, you're right, I should. Actually, purely for not readability, I should. Okay, any questions on how we got this? Yeah.
So should we include that small?
What's sorry?
Should we include that small, like the one we did before? We did like small pieces?
Yeah. So if the NFA was built like this in these small pieces, then yeah, we could. But are all NFAs like this? What could happen? Could I have something from the final state go back to the start state? Yeah. In fact, I can have anything from anything to anywhere. Well, let's look at this for a second. Suppose that we, instead of having just one state on both sides, we have a bunch of states. So let's just say we have some state. I'm gonna call it Q for the middle state. And I'm going to have a bunch of states on the left. And I'm going to have a bunch of states on the right. And all of these are going to come in here. And so the left states are going into Q. And we'll say what they are in a second. And Q is going to have out transitions to the things on the right. So it's going from the left to the right. And let's just say that the transitions on the left side are R1, R2, R3, R4, etc. And then let's just call it R sub M. And on the right side, we have S1, S2, and then it goes all the way down to SP. One of the issues with this class is naming things because you run out of things quickly. And to further complicate things, let's put a self loop on Q called X. People outside are going to look at this and going, what in the hell are they doing? So anyway, let's just say we have some bunch of R's coming in, so some symbol for each one of them, some symbol for the self loop on Q, and some symbols coming out. Well, how would I describe the ith state on the left side going to the jth state on the right side? Suppose I want to actually remove Q from the machine. Because if I have a lot of states in the machine and I tell you how to remove one of them, if you just repeat that procedure over and over, could we have anything different than this two-state NFA? Well, we could have some stuff coming back, but we'll deal with that. Isn't two states a lot better than more states? Yeah, because with two states, there are only a certain number of transitions. If we have a lot of states, then we have a lot to deal with. So if I tell you a way of removing the Q state in the middle such that everything else in the machine stays exactly the same, the language doesn't change, then you could just pick a state and then remove it as many times as you want until we get down to two states, and then everything's easy. So let's just say the ith state on the left side is state R. Maybe I shouldn't call them Ri. Let's call it A sub I. No, maybe not A. B sub I. Let's do that. And then the ith state on the the jth state on the right side we're going to call C sub j with a transition in between. So how can I get from the ith state on the left side down into the state Q originally? We're trying to remove it, but how did I originally get there? R sub I, because BI is the ith state on the left side. So originally we had going in some character R sub I going in. So we had R sub I. Well, could I take that self loop on Q as many times as I want? Yeah, because it's just a self loop. So how do I write that in regex notation? X star. I know that there's going to be an issue because there's more than one thing on the transition. We'll deal with that. What about going from Q out to the jth state C sub j? What thing did I read on the way out? Sj. Yeah, so that'd be Sj. Okay, so if we were allowed to say, if we could augment these transitions to put this regex right in on the transition itself, didn't we just invent a way of removing one state and then simulating the ways to go in and then the ways to go out via another transition? Didn't we not change the language this way? Yeah, we didn't change the language. So the problem is, do NFAs allow you to do this? Can I put more than one character on a transition? No. So we're stuck, right? Class over, dismissed. No, I'm kidding. I'm evil like that. All right, so let's actually talk about what would you do here? So when we had DFAs and we saw this problem, concatenation and star, we couldn't do them with DFAs easily. What did we do? What did we say? Well, what did we do to the machine model? We said, oh, we're going to generalize things. We'll allow you to do this. We'll allow you to do this. What are we going to do here, do you think? We're going to generalize things. And in fact, it's so generalized, it's called a generalized NFA. So a generalized NFA, also known as a GNFA, ooh, a 4-character acronym. A GNFA is like an NFA, but it's going to have 3 conditions. Well, let's see. If we let's go back to the first example we had. If we had a simple NFA like this that has one start state and one final state, and just a single transition over, no other transitions, isn't that easier? Isn't that an easy thing to parse as to what the regex is, this first example? Don't all answer at once. Is this easy, the first example? Yeah, because I just read off the transition. If we had other transitions on here, would it be harder? Yeah, it'd be harder. So, and if we put regexes on the transitions, that'd be good. What if we had transitions coming into the start state? Would that complicate things a little bit? Yeah, that would complicate things a little bit. What if we had multiple final states? That could complicate things. What if we, because that's not in the simple example we have, what if we had things coming out of the final state? Or if there are more than one, all out of some of the final states. Could that complicate things too? Yeah. So let's actually restrict that. So a GNFA is like an NFA, but nothing going into the start state. Exactly one final state. And nothing leaving it, including a self loop. And each transition is a regex. Okay. Well, let's see. Could GNFAs have more power than NFAs?
No.
You sure? Well, we saw NFAs. We allowed you to have epsilon transitions and multiple transitions on the same symbol. Could that possibly have given us more power over DFAs? It could have, but we showed equivalence. Could doing this where you put a regex on each transition, could that give it more power? Possibly. Yeah, just because we will prove that they're equivalent. But just because it seems like they may be equivalent, it might not actually be in reality. Okay, so let's see. If I have a GNFA like this, and that means that if we see a state like this, where we have a bunch of things coming in, a bunch of things coming out, and we make all the transitions that account for that state being there, and then remove that state away, then we have one fewer state to work with. So then we look at another state, and then remove that state. Then we remove another state. And then eventually, could we eventually come down to something other than this two-state example? Could we have anything else? Well, think about it. If we're removing states, we're obviously going to go down to two states at some point. But if I have a state in a GNFA and I'm removing it, could I introduce a transition into the start state if there wasn't one before? Could I introduce one? No, because look at the transitions here. The only things in the results that have a transition into them originally had a transition into them. The C sub j state had a transition into it before, and now it does afterward. I'm not introducing transitions to states that didn't already have one. So that's not going to be violated. I'm not going to be introducing new final states this way, because I'm only removing a state. I'm not adding states. And each transition's a regex. Well, if these were regexes before, the thing on the BI to CJ state, that is certainly a regex too. So that's fine. So eventually this generalized NFA will eventually come all the way down to this simple two-state example with some regex on it. Wait a minute. So that tells us that any GNFA can be converted into a regex. Okay? So let's actually write that down. So we can make from a GNFA to a regex because we whittle it down to the two states, and then we say, oh, what is the regex on that single transition? And then we just made a regex for it. Well, what do we know now how to do with regexes? What can we make from a regex? A three-letter acronym. An NFA. Oh, so from a regex, we can make an NFA. Does that tell us that anything about GNFA's languages? No. It doesn't actually tell us anything. It could mean that they're definitely not more powerful than NFAs. Because it could be possible I can make an NFA that there's no GNFA for. But what if I told you, meantime, what if I told you I can go from an NFA into a GNFA? What would that tell you? What would that tell you about regexes and NFAs? I can go either way. If I have a regex, we already know how to make an NFA for that. What if I have an NFA? How do I make a regex for it? Go to GNFA, and then through this whittling down process, eventually get to a regex. Cool. So what is our goal here right now, this exact moment? Yeah, do the NFA to GNFA thing. So can I convert any arbitrary NFA into one that has these three properties? If we can, we're good. So how do I handle the first property? There's nothing coming into the start state. So let's fix the start state. How do we fix the start state in an arbitrary NFA? So let's just say we have our NFA here. And then there may be things coming into it we actually don't know. How do I make this so that I make a GNFA which has nothing coming into its start state? Oh, create a new start state. This is our technique from before. So let's make a new start state, and then what do I do with it? Yeah, epsilon my way in. Should I make this new start state final? No, because there's no reason to. If the original start state was final, it wouldn't do anything anyway, because I can just epsilon my way in. Great, so we know how to do one. What about fix final states? I'm going to do it on the same black box over here, literally black box. So let's just say we have some number of final states, like say 2. How do I fix this so that, and there could be things coming out of here, I don't know. How do I fix this so that there's nothing leaving a single final state? Oh, new final state. Okay, so let's make a new final state out here, and what do I do? How do I hook it up?
Epsilon?
Yeah, epsilon my way in. From where? All states previously, or what?
All final states.
All final states, yeah. Is that it?
No, then you make the past final states not final.
We make the past final states no longer final. Wait a second. Me acting very surprised. Is there anything coming into this start state? Into the start state. Is there a transition going into that state?
Yeah. Wait.
Is there anything going into this new start state? No, good. It's only 9 o'clock. All right, we have 22 minutes. Is there anything leaving this single final state?
No.
No, good. Phew. Is everything on all of these transitions regexes? Well, let's be sure. Well, everything on the transitions is either what or what. It's either epsilon or a character. Is epsilon a regex? Yeah, that's in the definition. Are single characters regexes?
Yes.
Yeah, it's from the definition. Cool. So in fact, by doing this, we know how to convert from any NFA at all to a GNFA, and then we can use the whittle states down procedure, which we'll do an example, to go to the two-state thing, and then we can make a regex from that. So what do you think my plan is right now? What would you guys like right about now? An example. Probably to go home, but an example. Example will definitely help. All right. So let's try to think of an example, and by try, I mean me. Let's see. Q0. Let's do A. Let's make the symbols A and B to switch things up. Okay, so this is sufficiently complicated. So we have a three-state thing. Actually, let's make Q2 also final. Just so that it makes it even more complicated. Okay, so we have an NFA right here. I want to make a regex out of it. So what do we do? Oh, new start state. Should I do that all the time or just in this example? All the time, because it's algorithmic. So I'm going to make a new start state QS and epsilon my way in. Is that it? No. Shoot. Can you guys help me? Oh, new final state. Okay. Oh, I see the example over here. Okay, so let's make a new state QF, make it final, and then can you guys help me out? What do we do? Oh, epsilon transitions. Oh, from what to what? Oh, the Q1, Q2, the original final states to where? To QF. Okay, great. We epsilon our way over. And then, is that it? Oh, yeah. We made them non-final before. Okay, great. You guys are super helpful. I like it. All right. I want to remove QF. Is that a good idea? No, why is it not a good idea? It's the final state. Oh, so let's not do that. Let's remove QS. It looks like a simple state to remove. No. Why not? I don't want to touch that state. Okay, well, what are the states that I can remove? Q1 or Q2. What about the Q0? Yeah. Does it matter what order I do them? Why does it not matter? Well, look back here. Did I assume anything about the number of states coming in and the number of states leaving this state Q that I'm removing? Ah, so in fact, the method is so general that we can remove any state we want. Pretty dang cool. So, what one do you want to remove? We can remove any one you want, but which of the three do you want? Let's do Q2. Perfectly good. So, in order to know what the transitions are, if we're to remove Q2 out of the picture, what do we need to know? We need to know what's coming into Q2 if there's a self loop on Q2, and what, if anything, is leaving Q2 going somewhere else. Okay? Well, the way that I like doing this, and the way you should do it, is I make two lists. I make a list in and out. And now I'm hungry. Yeah. In and out. All right. So by in and out, I mean I write in the in column all of the states that go into Q2 that are not Q2. So basically it comes outside of Q2, goes into Q2. So what are those states, if any? Q0 and Q1, because Q1 comes in on the epsilon transition, Q0 comes on the B transition. So Q0 and Q1. What are the ways that we can leave Q2 going somewhere else? Not Q2, going somewhere else. We'll deal with the self loop later. It can go back up to Q0, which is good. Or it can go where? QF. So we have two ways of coming in and two ways of leaving. How many transitions are we going to add? 4. Because it's just two ways possible times two possible ways of leaving. Because I can pick any of the two ways of coming in and independently any of the two ways leaving. So I'm going to copy this because I can. All right, so we got this. And I'm going to just delete the state originally and so that we can see what's going on. So let's pick one of the ways in and one of the ways out. So pick one. We'll deal with all 4 eventually. We'll pick a way in and pick a way out. Q0 and Q0. So let's deal with that one. So eventually, what will this be in the now updated machine? It'll be a self loop on Q0. So we're making a transition from one of the states in the in column to a state in the out column. So from Q0 to Q0, that looks like a self loop to me. So eventually we're going to put a self loop on this guy. What goes on that transition?
Yeah.
Let's be careful. So what is the thing? What is the regex that we read going from 0 into 2? What did we read on the way? B. So let's write that down. B. Is there a self loop on Q2? Yeah. So how do we write that in regex notation? A star. And then what do we read on the way back? A. Anyone see a sheep? Ba. Okay. I promise I didn't do that on purpose. Okay. What was I going to say? Okay, so we handled the 0-0 transition. Here's a thought exercise. Let's just all put that back. What if there was no self loop there? It would be BA. What is the self loop on Q2? There actually is a self loop on Q2. What is on the self loop on Q2? I'm not crazy. No, there is a self loop on Q2 itself.
Epsilon?
Not epsilon. Empty set. What is empty set star? What is in the star of any language? Epsilon. So that's actually why we got BA out of this. B, epsilon, A, which just shortens up to BA. So in fact, all the transitions not shown here are just empty set. So it's just a good thing to think about when you have nothing else to think about. Okay, so we handled one of them. Pick another in and out combination other than a double-double. Q0, QF, let's do that one. So eventually we're going to make a transition from Q0 to QF. what's going to be on that transition? So what is the way into Q2 that we consider from Q0? B. So let's write that down. What is the self loop on Q2? Write it down as A star. How did we get from Q2 into QF? Epsilon. So there you go. So think about what we're doing here. We're modeling one of the ways in and then back out as a separate transition as the regex that corresponds to that way. Yeah.
So concatenating epsilon to it just removes it, simplifies?
Yeah, so remember, concatenating epsilon means, well, you're sticking a string with no length on the end of something, so that doesn't really do anything. If you union it, that's different because it's a string or a completely different string, which is different. Okay? So it's BA star in this case because it's just concatenation. What's another in and out combination? Q1, Q0. Let's do that one. So we're eventually going to make, let's do it in a different color to make it easy to see. We're going to eventually make that transition. So now, what is the way we go from Q1 into Q2?
Epsilon is the right.
Let me get there. Epsilon, right? What is the self? Yeah, go ahead. You have to speak up.
I have a question.
Yeah.
So our first one from Q0 to QF, we did BA star, right?
Yep.
But there's another way to get there. Why are we ignoring that option?
Oh, another way to get there, from where to where?
Q0, Q1, QF.
Right. Exactly. We're only considering paths of length 2 that go through Q2. So anything that comes in, because we're moving just this one state, so we're not considering any path that ignores that, that doesn't involve Q2 here. We're eventually going to address it when we remove another state. But think about what we're doing. When we're removing Q2, we're simulating via other transitions any way you could have went through that state. If you went not through that state, because I'm just removing that one state, nothing actually changes for you. If you just completely ignore Q2, as your example is go the other way on top. But if you go through Q2, I'm simulating it through a different way. Other questions? Okay, so what will this transition be? Well, we have epsilon so far. That's from Q1 into Q2. What is the self loop on Q2? A star. Excellent. Okay, great. And then from Q2 out to Q0, what is that? Just an A. Cool. Are we done? No. What else do we have? Q1 to QF. So eventually we're going to make it, oh, wait a second. There's a transition already there. What do we do?
Union.
Union. Okay, great. So what are the ways that we could go from Q1 into Q2?
Epsilon.
Just epsilon. Self loop on Q2, is there one?
Yes, sir.
A star. What is the way from Q2 out to QF? Epsilon. Good. So, oh, wait, we just handled all 4 possibilities. Are we done with removing Q2? Ah, cool. So we can remove Q2 and all of the transitions that originally were involved because we replaced them by new transitions that weren't there. So this is the machine that we have now. So I'm going to make this cleaner. Make it nice and clean. Any questions about that? Yeah.
Wait, just a clarification. So we can use transitions as like concatenation of characters because it's a generalized.
Yeah, because they're regexes. Mm-hmm. Yep. So now it becomes a little bit more complicated. Yeah, go ahead.
you're saying that you kind of need Q2 in the path
Mhm.
when you remove it, but for Q1 to Q0, where is the B star coming? Or I guess you already erased it.
Yeah, so what we were doing is we're simulating it
Okay, got it.
a different way.
Wow, that's key.
Anything for you guys? Any other questions? Going away from me. Oh, whatever. I'll just do it myself. Faster anyway. Okay, so cool. So are we done with the whole method? No. What things do we have to do?
Remove Q0 and Q1.
Remove either one. Does it matter?
No.
No. Okay. So which one do you want to remove?
Q1.
Okay, let's do Q1. Do you think there's a strategy of what states to remove? Yeah, so if there are more paths through it, then that's a state that you probably shouldn't remove. But does it matter for correctness purposes? No. Okay, so let's remove Q1. What are my in and out lists? What are the ways into Q1 from somewhere else? Q0. And in fact, that's the only way. Great, 1 on the left side. What are the ways I can go from Q1 to somewhere else? Oh, I can go to Q0, or I can go to QF, it looks like. Okay, great. So how many transitions are we going to add? 2, because it's 1 times 2. So let's do the Q0, Q0 way. Oh, there's already a transition there. Bah. What do we do? Union. Okay, great. So how did we get from Q0 into Q1? Just a single A. Oh, is there a self loop on Q1?
Yep.
A B star. And how did I get from Q1 back to Q0 someone else? A star A. Sorry. Excellent. So that handles 1. What about the Q0, QF one? We already got a transition there, so we use our good old friend union. So what are the ways we can go from Q0 into Q1? A. You're free to answer now. Self loop on Q1? B star. And then now, here comes the parentheses. Originally, here come the British. Here come the parentheses. So what do we? How did I get from Q1 down to QF? Epsilon union A star. So am I right to say this? No. What do I do? Parentheses. Good. Oh, that handles everything we need. So, in fact, I can remove now everything that involves Q1. And so now everything becomes a lot simpler. You know what? This looks a little complicated. Do you think I can rename some of these regexes to be something else?
Yes.
Ah, let's do that. I'm going to call the top guy R1, and I'm going to call the bottom guy R2. What state should I remove now?
Q0.
Q0. Okay, great. It looks like the last one, I think. So what are my in and out lists? What things go into Q0? QS is the only one. What are the ways I can go out?
Q1.
Just QF. Oops, that's not a Q. QF. Oh, so that means that we're going to have a single transition eventually to QF. Whew. What's going to be on this transition? These look like big regexes. Oh, R1 what? R1 star. Oh, that's the self loop thing. Okay, great. R1 star.
R2.
R2. Oh, concatenated or unioned? Concatenated, yeah, because it's right after it. Are we done? Is this a regex? Is this a regex? No, what is it?
NFA.
A GNFA, right? What is the regex we're after? Ah, the thing on the transition, which in this case is? Oh, yeah. So the regex is R1 star R2. This is a issue that some students in the past in my class and other ones have done, which is circle this. I asked them to produce a regex. They circle that. That's the regex. It's not the regex. It's a GNFA. The regex is the thing on the transition. I think you had a question? Oh, great question. What about this epsilon coming from QS on the front? It got concatenated in. Concatenating with epsilon does nothing. Any last questions? Yeah.
What about the epsilon R2?
Yeah, leave it there. Yep. Because it's unioning with something. That's different. Yeah.
Are we allowed to rename arbitrary transitions earlier?
Yep. If it's sufficiently complicated, then yeah. You have to speak louder. Yeah. Oh, good question. So if you remove states in a different order, you'll get a different looking regex, but it'll have the same language. So it'll look different, but it'll have the same language always.
As far as simplifying the transitions, like renaming that, do you want us to do the one that's
Oh, no. So R1 star R2. Yeah.